do that a lot, right? I went ahead for it. How hard? All right.
Okay, so part of the instructions for you was for you to go ahead and start, filling this part out, because this should all be review on this front page here.
Do we write that for regular pencil?
Yes,
Oh.
we're gonna shade some today. That's what the colored pencils are for. So in your slope-intercept form, your y and your x are always there. The things that change are your m. All right, what does your m stand for?
Slope.
The slope. Your m is your slope. It's the constant rate of change that happens in your problem. And your b, I have to sharpen it. And what does the b stand for?
The y-intercept.
The y-intercept. So in my equation right here, what is my m going to be? What's my slope?
3. 3/1.
Okay, so my slope is 3. Okay, and like AJ said, when we actually graph it, we want to think about it as 3/1, so we can do rise over run. Okay. What's our b going to be?
1.
A positive 1. Okay, so notice that it does say that the first step is to find and graph the y-intercept. So where is my y-intercept? Where is?
It would be 0, 1. So
0, 1. So from the origin, do I go up 1 or do I go forward 1? Up 1. Okay, that's where I'm seeing mistakes at. The y-intercept is where it crosses the y-axis. And then, how do I count the slope? From this point right here, I'm going to go rise or up 3 and run over 1. So 1, 2, 3 up over 1. Now that I have 2 dots, that's all that is needed, right? To draw my line.
You can make a third line if you want, or a third dot if you want.
I could. And how would I go about making my third dot?
You would go down 3, or left 1.
So go back to my y-intercept, right? And go down 3 and forward, and backwards 1. Okay. So I can also do -3 over -1, because doesn't that reduce to still give me a positive number? So this next one is in standard form. And I gave you a shortcut to help you with this, but for the purposes of this paper right here, we're going to work it out like it says right here. Okay, so here's my color coded again. So my x and my y are always going to stay the same, right? A, B, and then we have C. So my steps here, here's my equation. Okay. 3x plus 2y equals 6. Find the x and y intercepts for your graph. Now, the y-intercept is when x is 0, right? That's the definition of the y-intercept. So to figure out what the y-intercept is, if we substitute a 0 in for my x right here, okay, so I would get 3 times 0 plus 2y equals 6, right? So what does 3 times 0 equal? 0. So we don't have to include that, right? Because 0 plus 2y is still going to be 2y. Okay. So then when I solve, I'm going to divide by 2, right? Divide both sides by 2. So what does my y-intercept equal? 3, because 6 divided by 2 is 3. Now if we use our shortcut, right? Let me pull my paper down a little bit. If we use, can a chimp blow a bubble, right? The second one is my y-intercept. So C divided by B, is that not what we ended up here when we worked it out by substituting in a 0?
Yeah.
Okay, that is the reason the shortcut works, because when you substitute in a 0, it cancels out that term with the x in it, and it only leaves you whatever's in front of your y. Does that make sense? So if we do the same thing for my x-intercept, and I substitute a 0 in for y, I would have 3x plus 2 times 0 equals 6. So what happens when I have 2 times 0? 0. So adding 0 to something doesn't change it, so it cancels. So I've got 3x equals 6. Divide by 3. Okay, so I get x equals 2. So if I did the same thing up here, right, c divided by a, isn't that what we ended up doing down here? Okay, so this is why the shortcut works, but do you have to use the shortcut to figure it out? No. If you know that the y-intercept means x is 0, you can substitute in 0 and get your y, and vice versa for your x-intercept. Substitute 0 in for y and solve for x. So you don't have to remember the shortcut. So now what do I do? Graph these points. So where's my y-intercept going to be?
I'll 0, 3, and it's going to be just up 3.
Okay, so up 3, 0, 3 right there.
And then it'll be 2, 0, which is the over 2.
Okay. So there's my 2 points. Now I can graph my line. And this is where people start making mistakes. Okay, and this is something that you do have to remember on for testing and stuff. You do have to remember that if there's only one variable and it's a linear equation, if there's only one variable, that means it's either going to be a horizontal line or a vertical line. So right here, y equals c. C is just a number. It's a constant. There's no variable on it. Okay? So c equals a real number, a constant. So when our equation says y equals 2, well, where does y equal 2 at?
What's it called? What it means to y.
Okay, so well, it's going to equal 2 right here because my x equals 0, right? The coordinate for this point is 0, 2. So the y is 2. But if I put a point right here, This is 3, 2. Is my y not also 2 right there on that point? What if I come over here? Is my y not also 2 at this point? Negative 5, 2. So when we have an equation that says y equals 2, it means, okay, all of the points that y equals 2 on. Well, y equals 2 on this whole line right here. That's why we get a horizontal line for y equals 2, or y equals any number. So if y equals 0, what line on the graph would that be?
The entire y, or no, the entire x.
The x-axis, right? It's a little confusing on that. So, but if y equals 0, it's the entire x-axis, because your x value can be anything, and your y value stays 0 on that line.
In that situation, wouldn't it just be x equals all real numbers?
Yes, x would equal all real numbers. So your domain would be all real numbers, but what would your y value be?
0.
Your range would be 2 or 0. Yeah, if you're talking about the one on the x-axis.
Yeah.
Yes. So a vertical line is the other direction. Okay, so it's still y equals, or it's x equals c, sorry. Your y equals is going to be a horizontal line. Your x equals is going to be your vertical line. Okay, for the same reason. Because when x equals negative 4, it's not only at this point where it's negative 4, 0, but it's also up here at this point where it's negative 4, positive 4. Okay. Down here at this point where it's negative 4, 2. Okay, so we're looking at all of these, right, are negative 4s. Just like over here on this one, all of my y's were 2. So this is why I get a vertical line when it's x equals a number, because the x value always stays the same, but the y value changes. So let's recap about the slope on these two lines really quick. Okay, if I had to count the slope from this point that I plotted to this point on my horizontal line, what would my rise be?
0.
0. So my rise would equal 0, and what would my run equal?
3.
3. Does it matter what my run is if my rise is 0?
No.
No, because what is 0 divided by anything?
0.
0. So my slope for a horizontal line is 0. Now, if you come over here and we do this line, okay, and I do my rise over my run, what does my rise equal from this point to this point? 2. So up 2, okay, and my run is 0. I didn't go anywhere. Can I divide by 0? Am I allowed to have a 0 in the bottom of a fraction?
Yeah.
No. This is why if you put that on your calculator, you would get UNDEF. That means undefined. That is the type of slope it is. This is an answer just like this is an answer. They're two separate answers. A 0 slope is not the same as an undefined slope. Why can't we divide by 0? Because technically, if you have something, can you make 0 groups of it?
No.
No, it's not possible to make 0 groups if you have something.
Unless it's food.
Right? Even antimatter, for those of you that might be really big geeks. Okay, you still technically have something, even though it's antimatter. Okay.
What if it's food? It's not conditioned yet and it's not there.
So, but then you subtracted it, you didn't divide it, right?
I guess.
Okay. So you can't divide something into no groups if you have something. So this is why this doesn't work. Okay, why it's undefined. Because it just doesn't logically make sense. If you have something, you can't put it in 0 groups. You have to have one group of it, or you can split it into smaller groups, but you can't have 0 groups if you actually have something. Does that make sense? Kind of, sort of, why we can't divide by 0 and why the calculator gives us undefined. That is, okay, the answer, undefined. And that's spelled all the way out. Your calculator will just abbreviate it like that, and that's fine. Okay, so now look at the second sheet.
What's today's date?
So remember how that when we were graphing on a regular number line, if we had the less than or greater than symbol with no line underneath of them, what did we represent those by? An open circle. So on a number line, we represented these with an open circle. Okay. What did we represent the less than or equal to or the greater than or equal to with? Okay. So these are represented with a closed circle. Now, when we're talking about a linear inequality, we have to abide by this same rule, except for it's really not very pretty looking when that your graph has a whole bunch of circles like this on it. Okay, this doesn't make it easy to read. Okay, so if that we graphed a line, okay, so say here's my line right here.
That looks like it'd be no on the chart graph.
Okay, so here's my line right here. But I have all these circles are confusing on there, right? More so than just having the grid lines. Okay. So instead of drawing a bunch of circles saying, okay, this is my line right here, but it doesn't include my line, it includes one side or the other, which is what we're going to talk about. We don't draw just all these open circles. This is why we use a dashed line. And a solid line would signal that it's included like a closed circle, because then we would have all of these circles filled in, including all of those points. So we get a solid line because it's continuous. So the very first thing when you're looking at graphing an inequality is you have to determine whether you're going to have a dashed line or a solid line. So you're just looking at the inequality symbol. So down here in my very first example, what is my symbol going to be? A dashed line or a solid line? A dashed, because it doesn't have the or equal to. Okay, so dashed. Okay, I will usually refer to this as dotted. So if I call it a dotted line instead of a dashed line, that's what I'm talking about. So what is my slope of this? Other than the dashed or the dotted, you graph this exactly the same way as you do a linear equation to start with.
2/3.
Okay, so my slope is 2/3. And what is my y-intercept?
1.
Okay. So now I'm going to go down here just like I did my graphs on the front side. What's the first thing I'm going to graph?
The y-intercept.
The y-intercept
Just off 1.
of 1. Okay, and then what's my slope?
2/3. So rise
So-
2, 1, 3.
So rise up 2, 1, 2, and over 3, 1, 2, 3. Okay. So I have 2 points. That's enough. But if I wanted to make sure my line was straight, if I didn't have a ruler especially, right, down to backwards 3 would also give me another dot. Now, normally we would just do a line, but what do you have to do this time? A dash line. So if you already drew it, okay, you might need to go and just erase sections of it. Okay, that's fine too, but you're going to have a dashed line. It's not going to be solid. Okay. Now, remember on a number line, after we did our closed circle or open circle, we had to shade one way or the other because it included everything going that way or everything going the other way, right? The same thing happens here. We have to shade one side of this graph. We need to know which side to shade. So this is where the test your point comes in. So pick any point at all that is not on this dotted line or on your line. You don't want to pick one that's on your line. You need it to be on one side or the other. I suggest, okay, this is always the easiest point to pick. If that it does not go through your line, if your line does not go through the origin, use the origin because it's the easiest thing to multiply by, right? Anything times 0 is what?
0.
0. Are you really having to do any math if you substitute in a 0 that you're multiplying by? No. So we've got 0 because I'm substituting 0 in for my y, right? This is my x and this is my y. So 0 is less than 2/3 times 0 plus 1. Well, what's 2/3 times 0?
0.
0. So 0 plus 1 is
1.
1. So my final answer here is 0 is less than 1. Is that true?
Yes.
0 is less than 1. That is true, which means this is my true side, and it's the side that I'm going to shade. Okay. If you wanted to double check, you could pick any point over here on the other side. Because it's got a 3 in the denominator, I would pick 3 something. So if I did right here, and I substitute in, and just so I can show you what, so we've got my other point of 3, 0. Right? And if I substitute in, I would have 0 is less than 2/3 times 3 plus 1. Oh, that's -3, sorry. So it's on the negative side, so times -3. So 2/3 times -3 gives me -2 plus 1. So 0 is less than -2 plus 1. What is -2 plus 1?
-1.
-1. Is 0 less than -1?
No.
Wait, no, it's greater.
So that's false, right? So this is a false answer. So this side is, the reason this side is not shaded is because it wouldn't make our equation true. We only shade the side where all of the points are going to make our equation true. So the only addition, well, I guess there's 2 additional steps to graphing an inequality versus just a regular line. The first is deciding whether it's dotted or solid. The second is picking a point to know which side to shade. All inequality graphs have to have a shaded side because that's telling me what all possible answers. Okay, these are all possible answers. Okay, everything that falls in this side, any point that's on this side could be substituted in and give you a true answer. So if this is less than, it's going to be shaded down the y-axis. So that's one way that's what should happen if you plug in a point. But that rule only works if it's a y by itself. It doesn't work always in a standard form equation. So for this one, we couldn't necessarily use that rule because it's not in slope-intercept form. Okay. So looking at the symbol for this one, it's going to be solid. It's got this line underneath of it, right? So it's going to be solid because it's or equal to. Okay, how do I figure out this is my y-intercept, right? Because my x-coordinate is 0.
Yes.
So that means if I substitute in a 0 for my x, it's going to cancel that out, right? Because 5 times 0 is 0 minus 2y.
It'd be negative 2y, or negative 2. Yeah.
Mm-hmm. So 10 divided by negative 2.
Negative 5. Right.
Mm-hmm. So that equals negative 5. Okay. And now if I substitute in a 0 for the y, it cancels out my y term, right? Because negative 2 times 0 is 0. 5x minus 0 doesn't change it. So I have 5x is greater than or equal to 10. Well, that's 10 divided by 5. So what is my x-intercept equal?
2.
2. So graph these 2 points, 0, negative 5, and 2, 0. Okay. Now is it going to be a solid or a dotted line?
Solid.
Solid line. Okay, what point did I suggest that we pick?
0.
Pick your origin. If it's not one of on your line, you can pick any point. Okay, you can literally pick any point that's not on your line. I just choose the easiest one. Why make it harder on myself than it has to be, right? So if I substitute in 0, 0, I've got 5 times 0 minus 2 times 0 is greater than or equal to 10. Well, what's 5 times 0?
0.
0. And negative 2 times 0?
0.
So we've got 0 minus 0, which is
0.
0. Is 0 greater than or equal to 10?
No.
No. So which way am I going to shade?
The
The other side. If you get a false, that means that's not your true side, right? So you're going to shade the other side. Okay. So all my possible answers are on that shaded side. If you wanted to double check, you could pick another point on this side and make sure that you get a true answer. You do not have to though, but you do have to pick one point and see. So you may. Okay. So now you should be able to do your Get More Math. I don't have you graphing any of them on Get More Math. You just have to match the equation to what the graph should be. Okay.
And you want us to glue these 2 pages?
Yes, glue these 2 pages in your notes.